This episode of Serverless Chats is sponsored by New Relic and Stackery. This week, I finished my chat with Anahit Pogosova about streaming data at scale using serverless. This is Serverless Chats, episode number 92. So you mentioned this, you mentioned poll-based versus stream and things like that. So when you connect Kinesis to Lambda, this is the other thing too, I think that kind of confuses people sometimes. You're not actually connecting it to Lambda directly. For pretty much all of these triggers and these integrations, there's another service that is in between there. So what's the difference between the Lambda service and the Lambda function itself?
And that's a great one, because I think it's, again, one of those very confusing topics which are not explained too well in the documentation.
Right.
And the thing is that when you're just starting, like tipping your toes in the Lambda world, you just think that, okay, I write my code and I upload it and deploy it and everything just works and this is my Lambda, right? But you don't really know how much of the extra magic is happening behind the scenes and how many components are actually involved into making it a seamless service.
Right.
And there is a lot of components that come into, so you can think of a Lambda function as the function that you actually write and deploy and like invoke, but then the Lambda service is what does all the kind of triggering, invoking and batching and error handling. And it really depends on the way the Lambda works, or the way the Lambda service works. It really depends on the invocation model, as you kind of refer to, like the poll-based, not poll-based. So again, one thing that is not too clearly explained, in my opinion, is that there is actually 3 different ways you can work with Lambda or communicate with Lambda. So you can invoke a Lambda synchronously. So request response, traditional way. And like the best example, I think, is API Gateway, which does that. So it requests something from Lambda, it waits for the response. Then there is the async way, which is one of the most common. So you just send something to Lambda and you don't care about what happens next.
Which uses an SQSQ behind the scenes to queue requests.
Exactly.
Yep.
Yes, that's also like fun facts that you learn along the way. But the point is that like services like SNS, for example, or S3 notifications, they all use the async model because they don't care about what happens with their notification. They just kind of invoke a Lambda and that's it. But then there is this third gray area, or a third totally different way of invoking a Lambda function, and it's called poll-based. And that's exactly how Kinesis operates with Lambda. And it's meant for streaming event sources. So it's both Kinesis, DynamoDB streams. Also Kafka apparently uses a poll-based model. And it also works with the queue kind of event sources like SQS and SQS, Amazon MQ. I think they also use the poll-based method. And what poll-based invocation or the component that is most essential in the poll-based model, it's called the event source mapping, like one of the misunderstood components, or one of the hidden heroes, I would say, behind Lambda, because it's an essential service or essential part of the Lambda service. And event source mapping actually takes care of all that extra things that Kinesis plus Lambda combination is capable of. So it's responsible for batching. It's responsible for keeping track of this kind of point in the stream and where shard, where it's reading.
The shard iterator,
yes,
if anybody
exactly.
wants to
Shard
know the technical
iterator.
term for it.
Yes, thank you. And the most important for me, it handles the errors and retries behind the scenes.
Right.
And basically, if you don't have event source mapping, you can't have batching. So it takes care of accumulating. Well, in case of standard Kinesis stream consumer, it polls your Kinesis stream on your behalf. It accumulates batches of records, and then it invokes your Lambda function with that batches of records that it accumulated. Again, in case of enhanced fanout, of course, it doesn't poll. It gets the records from the Kinesis stream directly. But then from the perspective of your Lambda function, it doesn't matter. It just gets triggered by the event source mapping, because as you said yourself, it's not the Lambda that you connect to Kinesis stream. It's the event source mapping that you connect to the stream, and then you point your Lambda to that event source mapping. So
Right. So you can connect a Lambda function or the Lambda service directly to the Kinesis stream itself, or you can use enhanced fan out and push it to the Lambda function. Although
yep.
For all intents and purposes, it's pretty much the same thing.
Yeah. And for your Lambda function, it doesn't really matter how that data ended up or how those records ended up there. You just get a batch of records and then you deal with it. And I mean, all the rest is pretty much the same from the perspective of your Lambda function, because it's nicely abstracted behind the event source mapping, which kind of hides all that magic that happens behind the scenes.
Right. So you mentioned some aggregation stuff in there, and about like windows and time windows and things like that. So tumbling windows, that's something you can do in Kinesis as well. Can you explain that?
Yeah, it's a feature that actually came out very, very recently, in the end of the reInvent, I would even say. And I think it was like one day before I was going to publish my second part of my blog post. I was already kind of finally ready to submit it. And then in the evening, I get this and I was like, okay, I have to write a whole new chapter now. but it is a very interesting aspect. You can use it with both Kinesis and DynamoDB streams, actually. So it's available for both. And it's a totally different way of using streams, which wasn't there before. So with Lambda function, you know that you can't retain state between your function executions unless you are using some external data source or database. And here, what you are allowed to do with this tumbling window is that you can persist the state of your Lambda function within that one tumbling window. So tumbling window is just a time window. It can be at maximum of 15 minutes. And all your invocation within that 15 minutes max interval, they can pass the state and aggregate the state and pass it to the next Lambda invocation. So you can do cool things like real-time analysis that you could previously do only with Kinesis Data Analytics, for example.
Right.
Here you can do it right inside your Lambda. And then when the interval is ending, the 15 minutes, for example, interval is ending, you can send that data somewhere, let's say to a database or somewhere else. And then the next interval is starting and then you're aggregating again. And so it's pretty fascinating in the sense that it allows you to do something that wasn't there before. It's a completely different way of using the Lambda basically with the streams. But of course, there are limitations with that. You can only aggregate the data on the same shard because one Lambda is processing one shard at a time.
Sense.
And then there is also this thing called parallelization factor, which we haven't talked about, but but which basically means that instead of having one Lambda reading from one shard at a time, you can have actually up to 10 Lambdas that are reading from that same shard. So you can kind of boost the power of reading. Because if one Lambda, for example, if Lambda execution takes too long and kind of can't keep up with your stream, then you can either add more shards, for example, to your stream, but it's expensive, it takes time and has some limit, or then you can immediately just kind of throw more Lambdas at it, just say like more horsepower and they will take care of it. But if you have more than one Lambda reading from each shard, you can't use this new tumbling window feature. So which makes sense, of course.
Right, and it depends on what you're doing, because I mean the idea of the parallelization factor, such a hard word to say, but the whole point of that is to say, you're reading up to 1,000 records per second off of this stream. And if for some reason, it takes more than a second to process one of those records or whatever, then you're going to see the problem with not being able to process enough records quickly, and you're going to start backing up your stream if you're writing to it. So it's just one of those trade-offs, right?
Yeah, but again, this new feature, I think it's going to be developed still. Maybe someday it's going to have some kind of support for it, though I can't see really how under the hood it would function, like between different lambdas in the same shard. But anyhow, this I think is a very cool new thing that I'm actually eager to try out in production if I just figure out a case for that, because it just looks so cool and it's so simple to do.
Yeah, well, I mean, and the other thing is it depends on what you're doing with it. Like the use case that I've seen, and actually I started playing around with like SQS batch windows to try to do something similar. I know they're different, but they're same sort of idea where when you're doing aggregations, if you're just reading off a stream and you're trying to aggregate, you need to take you have to grab that data from somewhere, like you said, because lambdas are stateless. So you have to query a DynamoDB database or something like that, or a table, and then pull back what the last aggregations were, and then then you read in the data from the stream, and then you do your aggregation there, and then you write it back to the DynamoDB. If you're doing that, hundreds of times a second, that is pretty inefficient. Where if you just did it, set your tumbling windows to 1 minute even, and you could read thousands of records, and then be able to just write that back to the database one time. Just the efficiency gain there is huge.
Exactly. If you have a use case that is like that, because I personally don't. That's why it's I'm trying to come up with one in the future. Yes.
Find a problem for the solution.
Yes,
right?
Exactly. but it can be very, very helpful. And again, it's pretty straightforward using it. So I can see a lot of people loving it, really.
Yeah, awesome. All right, so another thing I just want to mention, because we keep talking about Lambda, and we mentioned the concurrency thing and some of those other bits. In terms of provisioning shards and having 1 Lambda per shard, and then potentially, if you do the parallelization factor, 10 Lambdas per shard, if you had 100 shards, because you had a lot of data coming in, and you had the parallelization factor turned on, then you've got 1,000 concurrent Lambdas being run at once.
And guess what happens next?
What happens next? Yeah, and if people don't know, the soft limit in any region is 1,000 concurrent executions for your Lambda concurrency. So that's just something that people need to think about.
Yeah, for sure, and that's something I bring up quite often because, well, been there, done that. But actually, 100 shards is not even too much. There are apparently streams with like thousands of shards, So we have something like 40 shards in our stream, so it's already quite decent amount. But yes, as you said, exactly. So if you have, for example, 100 shards, and then you have a parallelization factor of 10, you will have 100 times 10, 1,000 lambdas running or consuming that stream at all times. So there will be constantly 1,000 concurrent Lambda invocations. And you probably won't run into any problems until there is some other Lambda in that same region in the same account that is probably very business critical, that does something very important, and then it starts to fail for some unknown reason. And that reason is not even that Lambda. The reason is your stream, which is consuming the entire budget that you have allocated for Lambda. So yeah, it's something people oversee quite often, that though Lambda scales endlessly potentially, in reality, all the services, they come with these safety mechanisms of soft limits. There's no service in AWS, I think, that is kind of, it comes out of the box with no limits, just use it as it is. So they basically, for your own safety, there are some soft limits. And on the other hand, though they are soft, which means that you can increase them by submitting a ticket to support. It will take some time, I warn you, especially if you go kind of higher than normal. But though you can do that, there still is going to be a limit. There is always going to be a limit. And you just need to know that it exists, because one day you're probably going to hit it. So you have to kind of monitor that all the time. And yeah, that's one thing to keep in mind. But that's a common thing with SQS as well, for example, and maybe SNS. So all the services that can scale the lambdas pretty much like out of hands, then you are faced with that lambda concurrency limit that you have to be careful with.
Right. One limit that I love that has nothing to do with Kinesis, but with SNS is for if you send SMS messages with SNS, I think the default limit is $1 spend per month. So like if you send like 200 text messages or something like that, it ends up cutting you off. Maybe not 200. You probably had to send more than that, but it is a very, very low limit. And I think it's just because they don't want people, I don't know, spamming SMS or something like that. But
can you increase it? Is it soft limit?
Oh no, you can increase it. Yeah, but you have to submit the ticket. But I mean, but basically, I remember I set up a new account for something, and we were doing all these alarms, and it was like within 2 days, I got a message saying, no, you can't. No, you exceeded your limit. And I was like, well, that was fast. So, and if you're using something like Control Tower or any of these things to provision hundreds of accounts, some of these soft limits that are in there are, can affect you. So, whether it's Lambda or some of these other ones, but
It's surprisingly easy to reach all of the soft limits as long as as soon as you go to the real world cases,
Right,
from
exactly.
those hello world cases. And yeah, it's not a problem reaching the limits per se. The problem is many people don't know that they are there.
Yeah,
That's
yep,
when
good
the
point.
problems start.
Hey everyone, I want to take a minute to thank our sponsor, New Relic. Incidents happen fast, but they don't come out of nowhere. If your team is on top of things, then they can catch sudden shifts in performance and fix the issues before it impacts customers. But who has time to constantly check thousands of hosts, services, and containers? That's where New Relic Lookout comes in. Part of full stack observability, it compares current performance to past performance, then displays it in an estate-wide view of your whole system. If there's a sudden change, you see it right away, and it updates constantly so you get a real-time view of your system performance in a single glance. It's a totally different way to look at your system, and it actually gives you true observability. Sign up for free at newrelic.com and start moving faster than ever.
All right. So speaking of limits, there are limits obviously to Kinesis and some of these things that maybe even go beyond some of the soft limits. I mean, there's just limitations in distributed systems, and there's limitations in network throughput and some of those other things. And so as you hit some of those limits, or maybe let's just talk about errors in general, like as you start to kind of run up against problems, whether they're caused by limits or whether they're caused by something else. What are some of the things that I guess could go wrong when you're using Kinesis?
Right. Well, that's my favorite topic, really. But I mean, like with every service, as you said, I mean, nobody says it better than Werner Vogels, who says that everything fails all the time, and I love that phrase because that's true. And
very true.
Kind of, it's not because you want to be pessimistic, but rather because you want to be prepared. And you want to sleep better at night.
Right.
Because if you are not prepared, then surprising things will happen eventually. And for me personally, like with Kinesis or any other service, really, when I start working with a new service, like first things basically that I ask is that what are the ways in which it fails? What are the possible errors? What are the possible limits? Are they hard limits? Are they soft limits? All this. And even what's the built-in functionality for retries, for example? What are the default timeouts and that kind of thing? So those are very common things that you start to question after you have got a lot of headache with one of the services. And then you start to question those specific questions when you start working with a new service. And with Kinesis, you can probably separate the errors for like writing to Kinesis stream and reading to Kinesis stream. So for writing, first, it's nice that AWS SDK has a built-in functionality for retries for all the failures or system failures that happen, and timeouts as well. And it's not documented, or it used to be not documented too well, because personally I learned about the built-in retries when I was developing unit tests, and then they were behaving weirdly, and I was like, what? Something's going on here, what's that? And then I realized, it retries 3 times by default for every system error. And wonderful, that's a wonderful news. But maybe not so wonderful news is the thing called partial failure. And it's actually very common for all the services that are using patching. So what it means is that when you, for example, write a batch of records to Kinesis, it's not an atomic operation. It's not either the entire batch succeeds or the entire batch fails and you get an error code back from Kinesis. The reality is that you almost always get a success code back from Kinesis, and it's very misleading because parts of that batch could have failed and you don't know about that. And what you should do, instead of just looking for waiting for an error to come back, what you should do instead is to look at the response that comes back from Kinesis and to see if there is this field called failed error count or something like that, which basically tells you where there are actually failures within that batch that didn't go through to the Kinesis. And that can happen, for example, because of throttling. So some of the records just didn't make it. They didn't make it to Kinesis stream. So that's one of the basically like main issues that we have had with Kinesis streams. And you have to take care of those partial failures manually, and you have to do some smart retries and backoffs and random jitters and things like that. And then there are the timeouts, of course, which always happen, and you need to know the kind of the default settings for the timeouts, because in case of Kinesis, for example, the service times out after 2 minutes. So, and actually there are two timeout values. There is a timeout for a new socket connection, and then there is a timeout for sending a request. So first you will wait 2 minutes to create a socket connection, and then you will wait another 2 minutes for sending a request. Then it will be retried 3 times, and then like 10 minutes in, and you're still waiting for one batch to go through, like kind of in a pessimistic scenario. And again, those are things you don't really see in the documentation right away. Those are the things that you end up finding out because you have some problems. And the point is that you always have to set the timeouts to a lower value than the default 2 minutes.
Yeah, those defaults
it's crazy.
The defaults are not great.
No, not at all. So those are like the main things with writing. So like partial failures on timeouts and that kind of things. But with reading, things get even more interesting because there's so many options. And one of the things that is very common, it's called poison pill record.
The poison pill.
Oh, the poison pill, yes. And nowadays it's actually pretty avoidable, but let's get back to it later. But the idea of poison pill is that if you have a Lambda function attached to your Kinesis stream and it's reading from the shard and everything is fine, until there is some corrupt record in your shard for some reason. And your Lambda function tries to read that record and it fails. And then you don't have proper error handling because, well, who needs error handling? And then your entire Lambda function fails, right? And when your entire Lambda function fails, what happens is that Lambda returns, or as we know, event source mapping actually returns the entire batch back to the stream. And then it retries or makes Lambda retry with that entire batch that just failed.
And speaking of defaults, it retries 10,000 times, I think,
no,
by default?
You're too optimistic. By default, it retries forever.
Oh, forever?
Yes, it retries until the data expires, which means from 24 hours to up to 7 days or 1 year. But let's explain why it's not good. It's not a good thing. Well, first of all, you don't want to have all these kind of unnecessary Lambda invocations that don't do anything. They just send the same records and then they keep failing at the same point of the batch, and then they start all over again, and it's pointless. But the problem is that let's say 24 hours. Let's take the optimistic scenario. So in 24 hours, the batch expires finally, and Lambda can kind of forget about it. So the batch gets deleted from the stream, and then the next batch comes in. But the problem here is that by that moment in time, your stream or your shard is probably filled with records that were written around the same time as the records that you were trying to process, which means that they are expiring around the same time that the previous batch. And if your Lambda is not quick enough, you might end up in a situation when records end up falling from your stream, this overflowing sink analogy that I had in my blog post, when kind of you basically pour water to the sink more quickly than you can drain it. And then the water ends up on the floor. So that's the exact situation. So basically what ended up happening is just because of having one bad record and no proper error handling, you ended up losing a lot of, or you can potentially end up losing a lot of records. So hence the poison pill, because that one bad record poisoned the entire shard, basically.
Right. And I'm actually curious something. I've never tested this, but let's say that you get a batch of records that's only, say, 100 records because it's there's only 100 records in the stream. So it sends that batch to Lambda, and then Lambda fails because there's a poison pill, and it sends those 100 records back. If another 100 records come in because it's still under whatever your threshold was for batches, would it then send in the 200 the next time, and then would it keep sending in up to the full batch amount as it retries those batches?
I would imagine it should really. That would make sense. We just never had the situation because we usually have the complete batch
available. You have a full batch.
I would imagine that's how it should work. Yeah, because kind of it accumulates the entire batch, but it doesn't matter because it will stop at the exact same record. It processes them in order. Yep. It will stop at the exact same record, and then, well, of course, if you process them in order, you can process all the records in parallel if you want to. But then you won't have the ordering. But yeah, it's funny situation, and it's very easy to end up in it and been there, done that once again. But luckily, well, first of all, proper error handling in your Lambda function, where you don't allow the entire function to fail just because of one record that didn't go through. And then there are different ways to approach that. And then the things that I was talking about a lot or mentioning a lot is the error handling that comes out of the box with event source mapping. And nowadays, and actually it's developing, and each year they are adding new functionality and new possibilities that weren't there before. So what you said about 10,000 retry attempts, it's a totally new feature. It wasn't there. They added this maximum retry attempt setting to the event source mapping. But again, by default, it's -1, which means that it does it infinitely. So, but you can set it to up to 10,000 if you want to. And then you can set the maximum age of the record that Lambda will accept. So if the records get older than some specific age, I think it can be up to 1 week even. You can kind of, your Lambda will skip the records and won't process them. And then there is the on failure destinations, where you can send the information about your failed record if everything fails. And then I think that one of the fun possibilities is the called batch bisecting.
Yep.
So it's when you basically split your problematic batch in two, and then Lambda tries to send these two parts separately, and then like hopefully the other one succeeds, and then it kind of continues with the failed one and kind of splits it recursively further until hopefully you end up with just one batch record. Yes, but on the way there, you actually end up sending same records over or processing same records over and over and over again. So it's not kind of optimal. And then there was like one more announcement around the same time, because of which I had to update my blog post. I think it's called custom checkpoints.
Custom checkpoints, yep.
Yeah, it's where it's basically common sense. Instead of just failing your Lambda and saying, well, no can do. There was a batch, I don't know, something bad happened. Instead of that, you can return the exact sequence number of the record back to the stream, the record that caused the problem. So if you went on with your batch, you processed till record n, then you return that n back to event source mapping, and it knows that, okay, next time I retry, I will start from that n rather than kind of starting again from scratch. So that should eliminate the need to do the bisecting. Yeah,
right?
that's
the bisect. Yeah, right. So if you have an existing system that is using bisecting, you don't have to change it. But AWS likes to do that, where they'll keep the old functionality in, but there's a better way to do it. I mean, same thing with like dead letter queues and Lambda destinations, right?
Yes, exactly. But like for the sake of it, if you like the idea of just kind of splitting your batch and sending them separately behind the scenes without doing anything, well, you can have that. But yes, of course, that this new functionality would be so much better, because you would avoid all this unnecessary reprocessing of the same records. Yeah.
Hey everyone, I wanted to take a minute to thank our sponsor Stackery and tell you about their latest tool, Stack.new. Stack.new helps visualize and audit AWS CloudFormation templates against different aspects of AWS's well-architected framework so that you can make sure you're following all the best practices. All you need to do is provide a public GitHub template link or browse through a bunch of previously shared templates. You'll then get back assessments of IAM role scoping, encryption configuration, and a whole lot more, along with links to relevant guides to help make your infrastructure more reliable and secure. So visit stack.new today, give it a try, and make sure you share your feedback with the Stackery team.
So what are some of those other common issues? I mean, you mentioned timeouts and maybe like network issues are obviously happen, but what are some of maybe the other distributed network things that pop up when you're using Kinesis?
Yeah, I think that the timeouts and network problems are really kind of the core of it most of the times, really. And the other one that I've mentioned several times already, the at least once guarantee, so-called at least once guarantee. So the idempotency, basically with Kinesis, you are not guaranteed to get your data exactly once. It's at least once. So you will have duplicates in your stream. And it's because of, for example, the retry functionality. That we just discussed, both with sending and receiving the records. But also The fact that, for example, the network issues also kind of contribute to that, because you might have sent a batch of records to Kinesis, but never heard back from it. Like you just didn't get the message, so to speak. And then you will retry it because you don't know either it went through or not. And then maybe it did go through, and then you end up writing the same batch all over again. These are the things that happen pretty much all the time. And the only thing or the only way to deal with them is just to know that they happen and to be prepared for them. Like with at least once guarantee, your downstream systems must be resilient in the sense that they must be idempotent. They won't change if the same data comes over and over again. So they need to be handled to be able to handle that repeating records in your stream. And then with the network problems, well, there's not much you can do about network problems. Of course, if you have a producer that is running inside VPC, creating a Kinesis VPC endpoint is a good idea. So the kind of traffic won't leave your VPC.
Right.
So that's but pretty much that's the only thing you can do about those. But on the other hand, you can handle those issues with, or let's say timeouts are also network issues in some way or quite often. And the thing that we were discussing before, that default timeouts are really not that great.
Right.
Most of the time, you need to adjust those with Kinesis, especially, or not especially, but that's a good example maybe. But actually, one fun thing I remembered about the timeouts is related to DynamoDB, which are probably familiar to you in a sense, because the DynamoDB also has some ridiculous default timeout, like a minute, 2 minutes, something like that. And when a couple of years ago at reInvent, I was speaking with one of DynamoDB guys and was asking that, okay, we have this API that needs to retrieve data from DynamoDB, and it needs to be very, very quick. So latency should be very low. And we used to have like Lambda in between. So Lambda was doing calls to DynamoDB.
Yeah.
And the first thing he said was like, reduce the timeouts. Because apparently DynamoDB can time out pretty frequently. So it's much better to drop the connection sooner rather than later. So you set the timeout to, 1,000 milliseconds, and then you let the SDK handle the retry instead of waiting for like forever. But that was funny. That was the first thing they recommended me to do. Okay.
Yeah. But, even though they set those defaults pretty high. But
yeah, exactly.
All right. So then in terms of monitoring this, though, I mean, that's one thing that I really like about Kinesis is that you do get quite a few metrics where you can look and see how your shards are doing, how quickly, they're being drained, how backed up they are and stuff like that. Like what are some of those, I guess the most important metrics that you kind of want to keep your eyes on? Right.
So of course there are separate ones for writing to the stream and for reading to the stream. So I would say for writing, write throughput exceeded exception is like the metrics that tells you that you exceeded the throughput of your stream, basically. So that's the one that was pretty much eye-opening for us because, well, the thing with metrics in general is that they are at best minute-based. So they are aggregate metrics or aggregate values over 1 minute time, right? And with Kinesis, as we have mentioned several times, all the limits are per second. So it's 1,000 records per second, one megabyte per second.
Right.
And that's the information you don't get from the metrics. So you don't see the picture, kind of per second picture. So there is a metric that tells you how many records come in and how much of the data comes in. And you might look at those and think, okay, the threshold is still far, far away. I for sure have no issues with this stream. And then you notice that there is this provisioning throughput exceeded exception metric that is being kind of popping up, and you figure out that apparently bad things can happen even in this situation. Of course, it's because of, for example, the networks issues that we discussed before, or like spiky traffic, because like the records
traffic.
Yep, the records arrive to your stream ununiformly in a way. So it might be that one second it's like 5,000 records, and the next second it's just like 3 records, and you can't see that in metrics. In one metric, you have to kind of observe the metrics that tell you what goes wrong in a way. That's the key, I guess. And same goes to reading from the stream. Really, there is this read provision throughput exceeded, which is basically only for a shared iterator case. So the standard reading consuming the stream. So when you exceed, for example, 2 megabytes or you exceed this 5 requests per second, which we don't even go into. Read my blog post, you will know what I'm talking about. But you get those, and then there is, I think the most important one is the iterator age when it comes to reading from the stream, because that's the one that tells you the kind of age of the record, meaning like how long they have been in that stream. And apparently, if the age increases, it means that you can't consume them fast enough. So there you might have a problem there with your consumer, for example, or you have too many consumers and then you have to have the enhanced fan out and things like that. But there are basically like 2-3 metrics that you have to keep an eye on. And if you see any issues with those, then you have to dig deeper, maybe enable the enhanced metrics, which are not stream level, but they are shard level metrics. So for each shard, you can have the same or similar kind of information, so you can diagnose it more precisely.
Right. Yeah. And if it was only serverless, or I should say fully serverless, and did this automatically for us, that would be much better.
Yes.
Well. So just like your blog post, this episode turned out to be quite lengthy. But I hope people got quite a bit of knowledge from this, and are not afraid of using Kinesis, because it's an amazing service. Yes, it has all of those caveats that we talked about, but still an amazing service. But if you've got a few more minutes, I'd love to just pick your brain for a second, because I think there are a lot of common misconceptions about, building serverless applications, and again, whether Kinesis is serverless or not, we'll put that aside. But just all of these different services, even Lambda, and having to build in the retries and know about the either bisecting or using the custom checkpoints or doing some of these other things. There's a lot that goes into it. So what are some of the, I mean, maybe just, even from your own perspective, when you're building serverless applications or using fully managed services, like what are just some of those misconceptions that maybe people have?
Yes, I've noticed those, well, few of them actually, while working with serverless. And people usually have strong opinions, about serverless. It's either they go both ways. But I think many people assume that it's either very easy, or then and you don't have to do anything, everything is done for you, or then it's way too complicated. And I think again, Jan Cui had a nice blog post lately about the complexity of serverless, or perceived complexity of serverless. And what he was saying is that serverless is not complex, it just reveals the underlying complexity of the systems that we used to build before. So all these things that were built in and hidden from everybody's eyes, but they were still there, now they are more obvious with using all the different components, and you connect them to each other and you have all that ecosystem living there. But
which gives you more control over those individual components as well.
More observability, it gives you more control, and all these nice things why we love serverless. So I am all for it. But on the other hand, I think it's a simplistic view to think that fully managed and serverless, it means that you basically just deploy a code and you have to worry about nothing. Because as we discussed with you several times already, you will probably get away with that on the hello world level. It will be pretty much okay. But then when you get to the real world and real world scale, you actually do need to know in quite some detail how each and every service that you are using, how they work and how they fail. Because, well, once again, they will fail at some point. And you basically, you need to know how they fail and what can happen just to sleep at night,
Right. Yeah. And I also think just this idea, that, again, the set it and forget it, for simple things, like you said, yes, but it just ongoing management. All right. I mean, and optimizations and, and shards, refactoring code and like with the shards thing, like monitoring that and saying, okay, we're starting to creep up to this next level, or maybe we're not processing fast enough, or maybe our shard iterator keeps, pushing over a certain amount of time during certain times of the day.
I'm getting anxious now.
Yeah, right. I know.
Yeah,
you want to go back and look at all those,
exactly,
at all those metrics.
All but that's exactly right. But maybe it will sound scary. Well, we put it that way. But on the other hand, it reveals the complexity your systems do have anyway. And the good news here, I think, is that in case of AWS, there is a lot of commonalities in how services work. And
true.
once again, I think understanding one service like through and through will kind of help you to understand like all these issues with the distributed systems and the errors and built-in retries and whatnot. So you don't really need to remember every single thing by heart, and like it's not as overwhelming as we maybe make it sound at the moment. It's just it does require some work, but I think it's well worth it.
I totally agree. Well, Anahit, thank you so much for taking the time to talk with me and educate the masses about Kinesis. If people want to find out more about what you do or want to contact you, how do they do that?
Well, first of all, they need to read the blog. It's long, but I hope it's worth it, and it has some nice pictures, so some benefits. Then they can reach me on LinkedIn, first name, last name, and Twitter. Again, first name, last name, and I think that's about it.
Awesome. And then the blog at solida.fi, and then you've got a really good talk that you gave. I think it was at AWS Community Day, maybe Stockholm.
Oh my God,
like
it's been over a year already. That was the last trip that I made before.
Isn't that crazy? I know, it's been
horrible.
a year. It's been a year.
It's been a year.
We just celebrated, or celebrated, I guess. There was just a year passed for Serverless Days Nashville, which was the last conference that I went to in person. So
exactly.
I am looking forward to doing that again and bumping into people and talking to people about this in the hallway, because those are the best conversations. So
for sure.
Anyways, I will take all of this stuff, your Twitter, LinkedIn, blog, the two blog posts that you wrote about this, as well as that video talk from Community Day Stockholm. I will put all that into the show notes. Anahit, thank you again so much.
Thank you so much, Jeremy. It was so much fun.
And that's the rest of my serverless chat with Anahit Pogosova. I want to give a huge thank you to Anahit for being my guest this week, and to our sponsors New Relic and Stackery. If you want to check out the show notes and a full transcript of this episode, you can find them at serverlesschats.com/92. For more serverless chats, subscribe, sign up to be an insider, check us out on YouTube, and follow us on Twitter, Facebook, and Instagram. You can connect with me on Twitter at Jeremy_Daily, and if you want to keep up to date on everything serverless, make sure you subscribe to the Off by None newsletter at offbynone.io. Thank you so much for joining me, and I look forward to chatting with all of you again next week.